Hello, and welcome to our fifth and final section of Chapter 11 of our area chapter. Today we are going to talk about composite figures. Now, composite figures is exactly what it sounds like. If you know the definition of composite, it literally just means composed of more than one. So in this particular case, we're going to take some shapes, more than one shape, and we're going to kind of merge them together. And we've done a couple of examples of this already, and we're going to dive deeper into composite figures. So composite figures, or composite, just means it is a composition of two or more figures or shapes. So in this particular case, easy way to think about solving for composite figures is to separate them into regions of basic shapes. So for instance, the idea here is to separate, that's not how you spell separate. Separate the figure into basic shapes. So what I mean by that is, let's say we have like a silhouette of an ice cream cone. So here we're gonna draw ice cream cone. Something like this, okay? And then we will draw a half circle to represent the actual ice cream. And in order to do this, we would actually need a couple pieces of information. Let's pretend we have this whole length here, which is, let's say, from here all the way to here. Let's say this length is 4 inches. Then let's also say this altitude, or this height, is 5 inches. Okay? The area of this region, which I'm going to shade, let me get an actual highlighter, shade in red, can be calculated by breaking this up into two pieces. We have a half circle that has a radius of 2. R is equal to 2, because the diameter is 4. And then we also have the triangle. And we also know that the base is equal to 4 and the height is equal to 5. So when we do a composite figure, it's the best strategy is to break it up into shapes that we can actually calculate. So all we have to do is add these together. Area of a circle is pi r squared, but we only have half a circle, so we're going to say area in this particular case is equal to 1/2 pi times 2 squared. Okay, let's do some calculations. 2 squared is 4, half of 4 is 2, so this area is equal to 2 pi. And then we could say inches squared if we want to. Then the area of a triangle is equal to 1/2 base times height. Our base is 4, our height is 5. So 4 times 5 is 20. 20 cut in half is 10. Area is equal to 10 inches squared. Now the exact answer for this is just a sum of these two. Area would just then be equal to 10 plus 2 pi. You cannot add these together because pi is its own term, or it's like a variable. You can't combine terms that are not the same, or that are not like. So we leave it as 10 plus 2 pi inches squared for the exact answer. If we want the decimal answer, we just plug this into our calculator, 10 plus 2 pi, and we should get area is approximately equal to 16.28 inches squared. Okay, so that's an example of a composite figure. Let's look at something that is a little bit more complicated. So for instance, what if we have something that looks like this? let's take a rectangle. That's a bad rectangle. So this is example 1. Example 2. Okay. And let's make a rectangle. And in this rectangle, we're going to actually have, 2 circles. Kind of like a sunglass holder, right? And we're going to say that the radius of this is equal to, let's say it's equal to 6 millimeters. That's the only piece of information we have here. And we're going to say, let's calculate the area of the red region. So what is the area of the shaded region? So in this particular case, break this down into the shapes we see. We see a rectangle. Now, we see a rectangle that should have a, this is also 6, this is also 6. We also have it in this direction. We have it in this circle as well, in all directions, all of which is measured in millimeters. So in particular, we have all of the dimensions just by that one alone, okay? And to calculate this area, it would just be rectangle, the giant rectangle minus 2 circles, okay? And we could do this. This is not terrible, right? Break it up into parts that we actually know. So the rectangle actually has a base that is equal to 6 plus 6 plus 6 plus 6, 24. Then the height is equal to 12 millimeters. And the circle has a radius of 6, so we could use that in our area for the figure. So let's start solving. Area is equal to base times height, 24 times 12. 24 times 12 is equal to 288 millimeters squared. The circle area is equal to pi times radius squared, so 6 times 6, or 6 squared. Area is equal to 36 pi. But that is only for 1. We need to multiply this by 2, so please don't forget that. So area, so we take that area, multiply this by 2 for the 2 circles, and we get 72 pi, that's not supposed to be squared. That's supposed to be inches squared, or millimeters squared. So there's your 2 circles. And something's off about this. 6. 24 times 12. No, this looks okay. So, oh, that's right, because this is written in pi. So, if we want the exact answer, we just do 288 minus 72 pi millimeters squared. If we want the decimal answer, we do an approximation, 288 minus 72 pi. We should get an answer of approximately 61.81 millimeters squared. Okay? Now, the last thing I want to talk about, so that's composite figures. The last thing I want to talk about is circumscribed and inscribed circles. So this is going to be a little sub-note. I'm going to draw a circle. I'm going to draw, first and foremost, I'm going to draw a triangle. Then I'm going to draw a circle inside of this triangle. Let's draw this in actually red. And this circle, if I could get this down, is embedded into this triangle. Now, I can't draw this perfectly, but this is supposed to touch exactly at these points. Okay? This circle is what we call an inscribed circle because it is literally inside the shape. Okay? And then in green, I'm going to draw a circle that is what we call circumscribed. Because if you think of like a circumference is on the outside of the circle. It's that line that makes a circle. This is what we call a circumscribed circle. Meaning it contains the figure inside of it. So there are two versions of these types of circles. Inscribed means the circle is inside of a shape. Circumscribed means it is on the outside of the shape, or it holds the shape. Okay? So those are two subtle differences, and in this particular example that we just did, the circles were on the inside. These would be inscribed circles. Okay? So we'll have more practice with this in class. If you do have any questions, please let me know, and I'll see you in the next one. Bye.